Welcome. Simple harmonic motion. This is an introduction to simple harmonic motion, which will be followed by a set of solved problems to enhance your understanding. This is our spring, symbolized by K, which is spring constant. This is mass M attached to the spring. This is called equilibrium position. The spring in relaxed position, we choose X as origin. This origin is X equals 0. When the spring is relaxed, the net force is 0 in this position. The net force is 0. The object is in equilibrium at this position. If the object is now pulled to the right position, well, X equals A, at this position, and then relax, the net force on the object is negative spring constant X. This X is displacement. This K symbolizes the spring constant, like here, spring constant. Well, this negative sign tells us that the spring force is opposite in direction to the displacement from equilibrium. The total energy of the system is constant. Total energy of our system is constant. Total energy equal kinetic energy plus potential energy is constant here. It's a constant. Meaning that this mass, this spring, and this mass have constant total mechanical energy. Their total mechanical energy is constant. This K symbolizes kinetic energy. This U is potential energy. This elastic potential energy, this elastic potential energy stored in our spring is written as spring constant X square of the displacement. As the object oscillates back and forth energy is converted from potential to kinetic energy and back to potential energy in half cycle. Converted to elastic potential energy back kinetic energy potential energy kinetic energy potential energy. At the end point here, at this end point, kinetic energy equals 0. Kinetic energy equals 0 at this point, at this end point. At this end point also x equal negative a. X, the displacement, equal positive a, which is called amplitude. The total mechanical energy equal the sum of elastic potential energy plus kinetic energy. At this end point, kinetic energy equals 0. Kinetic energy equals 0. Total mechanical energy becomes totally elastic potential energy. At this end point, remember x equals negative a or positive a. It's why at this end point I write a square instead of x square. At this point here, at equilibrium position, well, x equals 0, we have maximum speed. The total mechanical energy at this point, well, x equals 0 is totally kinetic energy. Remember, at this point velocity is maximum. At this point the speed v is maximum speed. Now at equilibrium position, the total mechanical energy is totally kinetic energy. Well, the speed is maximum speed. As the energy of spring mass system is always a system, this total energy is always K A square, which is equal to kinetic energy at equilibrium, where we have V max. This is possible at this equilibrium position. Now, from this relation, we can find the maximum speed. The maximum speed at equilibrium position. Let's try to solve for V max. Maximum speed. Find maximum speed. We find K over M A square. Solving for V max, we find A root K over M. You see from this relation that the maximum speed is proportional to amplitude A. At maximum displacement also, here at this maximum displacement, the acceleration is maximum because the force, this force negative kx, is maximum. As our acceleration changes with time, let's try to find the acceleration. Remember, acceleration, the force equals ax, for example, because we are on this line x here. Trying to solve for acceleration, we have, so for this ax will be equal to negative k m xt, because acceleration changes with time. Now we can find the magnitude of acceleration. The magnitude will be maximum acceleration equal k over m times amplitude. Now, this was for introduction. If you go on our channel, you will find a set of problems related to simple harmonic motion, where we focuses on spring system to enhance your understanding of simple harmonic motion. Next video is a set of problems solved for you. Thank you for watching.